All right, everybody. Here is the next beginning of the next section. Now, hang on, I want to try and make this a little bit larger. There we go. Okay, beginning of the next section. So the last section, the one that we just got done working on, said postulate 3-2-1. We just call it CAP, corresponding angle postulate. If two lines are cut by a transversal, then the pairs of corresponding angles are congruent. So notice in this postulate, you're given that the lines are parallel, and then the corresponding angles are congruent. Here's the next section. It's called the converse of the corresponding angles postulate, converse of CAP. And we know from our last quiz that when you're talking about the converse, you switch the hypothesis and conclusion around. So take a look at how it works. Two coplanar lines are cut by transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So what you're given in this one are, the first one, two parallel lines. In this one, you're given congruent corresponding angles and the fact that they're cut by a transversal. The conclusion in the top one is then the pairs of corresponding angles are congruent. The conclusion in our new section is then the lines are parallel. And I'll just circle the parallel piece of that conclusion. So when we get done with this, if you were to describe this section in one word, it would be converse. Okay. And what it means is you're trying to show lines are parallel. Let's look at how that works as far as questions are concerned. So as an example, use the converse of the CAP and the given information to show that L is parallel to M. Last week, from Wednesday through Friday, everything we were given was lines are parallel. Now we're trying to show lines are parallel. Okay, so we're given this picture, two lines cut by this transversal. And it says this, use the given information. We're just given that measure of angle 1 is equal to the measure of angle 3. Look where those are in the pictures. Okay, they are in corresponding angle position. So if two coplanar lines, there's your coplanar lines, are cut by a transversal, corresponding angles are congruent. I would put arc marks here, but I'm going to use the same picture for the next question. Then the lines are parallel. So what do we say? So we say angle 1, since angle 1 is equal to the measure of angle 3, then L, or this line, let's call it L, and we'll call this one M. I forgot to label them. We'll call this one T. So L is parallel to M by converse CAP. You have to have the word converse in there. Well, how do I know? Again, how do I know, Feather, that I need to have the word converse there? Because I'm trying to show that the lines are parallel. Okay, let's look at a little bit more tougher and involved question. It says, same picture now. Measure of angle 7 is equal to 4x plus 25. Okay, so I'm going to go ahead and write that in there. 4x plus 25. And it says that angle 5 is 5x plus 12. 5x plus 12. And then it says x is equal to 13. Okay, so how can I show that those lines are parallel? Let's go ahead and figure out what angle 5 and angle 7 are, because they tell us that x is equal to 13. So just plug it in. So I get 4 times 13 plus 25. That's 52 plus 25. I get 77. So angle 7 is actually 77 degrees. Let's see what angle 5 is. If you plug it in, x is 13. I get 5 times 13 plus 12. That's 65 plus 12, which is equal to 77. So this angle has to be 77 degrees as well. Okay, but I didn't realize that until I plugged in those algebraic values. So since measure of angle 7 equals the measure of angle 5, which is equal to 77 degrees, L is parallel to M by converse of CAP. Okay, but you have to show this. You have to show that 7 and 5 are the same values. And we know that those are corresponding angles. Okay, thanks.